we started some discussion about the last class. In the last class, we started. I have discussed some linear momentum here. Linear momentum will represent by small p. Small p here. Small p is used for represent. Small p is used for representing the linear momentum. Okay, and small p means linear momentum means I can simply say that it's a product of mass and velocity. Product of mass and velocity. Mass and velocity is a product of mass and velocity is a linear momentum here. And as I said yesterday, that linear momentum is a vector quantity, is a vector here. And coming to the units for this, the units are kg, mass units are kg, meter per second, meter per second, kg meter per second is a unit here, and it's a vector quantity, correct? And we have seen this change in linear momentum means final momentum minus initial momentum. That's what we have seen in the last classes, correct? Last video we are discussing. These are the small some basic definitions we can say. At the same time, while finding this while finding this linear momentum, to see some examples, we require some vector resolution is required here. Means vector resolution, as I said yesterday in the last video, that is a vector is drawn in this direction a bar. Okay, got it now? A vector is in this direction. I can resolve this a bar into two components. One is along x-axis and the one is along y-axis. One is along x-axis and the one is along y-axis, correct? So this component, as I said here, is theta. This is nothing but ax cos theta, or simply I can write this one as ax. Okay, ax. So ax is nothing but a cos theta. We have seen in the last video. Again, once again, I will repeat it today. Just try to know this one. This will be the very useful for throughout the physics. And in the 2 years, vector resolution is much important. Ay is equal to a sin theta. Ay is equal to a sin theta. Understood here? Ax is a cos theta. Ay is a sin theta. So these are the resolution as we see in the last class. Now anyway, I will tell you I will repeat it why the need of, what is the need of this resolving the vector? What is the need of resolving a vector? Before that, let us see the basic concept. There is a coordinates are there. I am having the 3, 4 are the coordinates of a point. I am taking a point whose coordinates are 3, 4. What are the coordinates? 3, 4 as a coordinates, right? Okay, fine. So if observe here, this is the point, a point which is on the coordinates 3, 4. Okay, 3, 4 is the coordinates here. Here, what I am doing here is, what is the meaning of this one? What is the meaning of the writing the coordinates? Meaning here, I can say it is this point is the point P is at a distance of 3 in the direction of 3 meters in the direction of x-axis. Which direction? In the direction of x-axis. Okay, no? In the direction of x-axis. It is in the direction of x-axis. 3 meters. This point is 3 meters in the direction of x. This is x-axis we commonly take. And this is the y-axis. X-axis and y-axis, correct now? So this point is 3 meters in the x-axis direction. Okay, now? In the x-axis direction. Now if you observe here, I can say one more here. This point is at the same time it is of 4 meters in y-axis direction. This point is 4 meters in the y-axis direction. Correct? What is the meaning of 3 and 4? 3 meters in x-axis direction, 4 meters in y-axis direction. Correct? 3 meters in x-axis direction, 3 meters in x-axis. X-axis I will take it as I cap. I represents the x-axis, okay? I represents the x-axis, and 4 meters in y-axis direction. 4 represents the J represents the y-axis. It was in 4 meters, right? 4 meters in y-axis, okay? Now, fine. So this is the vector here. Actually, this is the vector. This is the vector A bar. A bar. Got it? A bar means A bar. What is the length of this one here? How can you see this point? Distance between the 2 points. How can we say? Distance between the 2 points, root of x2 minus x1 by y2 minus y1. The coordinates of the origin are 0, 0. 0, 0 means x1, y1. This is x2, y2. How to get the magnitude? Distance between the 2 points, x2 minus x1 whole square, 3 minus 0 whole square, plus y2 minus y1 whole square means 4 minus 0 whole square. Correct? How to find the distance between the 2 points? If the 2 points are x1, y1, one is x1, y1 and x2, y2. What is the distance between the 2 points? Distance between the 2 points, we can write this one as x2 minus x1 whole square plus y2 minus y1 whole square. In the same way, this point is the origin, another point is P. One point is origin here, point is P. What is the distance between these 2 points? x2 minus x whole square plus y2 minus y1 whole square. Correct? Is equal to how much again? Root of 3 square. 3 square is and 4 square. 3 square how much? 3 square is 9 and 4 square is 16. So I can get this one as 5. Root 25 is 5. So this distance is 5. How much? This distance is 5. Got it here? This distance is 5. Okay now? This 3 meters along x-axis. This is 3 meters along x-axis. This is 4 meters along y-axis. Okay? So this total becomes 5. So what I mean to say here is, I will tell you one more time, listen carefully. Yes. So I am taking a point, a vector is in this direction, which is 5 meters actually length, which we got no length, right? So it's having a component in this direction of 3 meters. And another component in this direction of 4 meters, correct? That's what we did. And this angle, I can say this is equal to 53 degrees somehow. 53 degrees. 53 degrees. This angle is 50 degrees, remember that one, okay na? 53 degrees, okay? So now if you observe here, what I am saying here is, I will write this 3 as, how I am writing the 3, check it here once. Okay, 3 as 5 cos 53. How much you get, amount? 5 cos 53. Cos 53 means 3 by 5. So how much I am getting here? This one is 3. Means what I mean to say is, just compare, you can easily, somewhat little bit easily you can understand. A, this A has been divided into 2 components. 2 components. One component is like this. Another component is in this direction. I am saying this one as a horizontal component AX along x-axis. Okay, na? And this component is along y-axis. So I am taking this one as a y-axis component. Okay, na? Y-axis, correct? AX, AY. 2 components. This component, this vector, making an angle theta with this. Just compare these two here. I can write this. You can see right angle triangle. See. From this right angle triangle, I can write this as cos theta is equal to AX by A. AX by A. Cos theta is equal to AX by A. Correct? So what is AX from here? From here I can write AX is equal to A cos theta. So this is the horizontal component. Horizontal component. Similarly, what is sin theta? From the same right angle triangle, sin theta is equal to how much? AY by A. AY by A. Correct? What is AY from here? AY is equal to A sin theta. AY is equal to A sin theta. Correct? These are the components. A vector can be easily resolved into 2 components. A vector is resolved into 2 components. One is AX cos theta, horizontal component, say this one as, and another one is A sin theta. Okay? A vector simply can be resolved into two components. Here, as 5 is divided into 3 and 4. Correct? As 5 is divided into 3 and 4. This is, I can say here, this one as a 3 and this is 4 and this is a 5. Correct? Right angle triangle. In the same way, A is divided into like this. AX and AY. What is AX? A cos 5. See here, for 3 is equal to 5 cos 53 proved. And similarly 4 I can write this one as 5 sin 53. Okay, sin 53. What is sin 53? Sin 53 I can write this one as 4 by 5. So we'll get one as 4. We'll get it as 4. Okay? So this is the resolving. A vector 5 is divided into 3 components. A 5 is divided into 2 components. Okay now? Got it here? So 3 and 4. 3 and 4. Now a vector A is divided into AX and AY. AX and AY. Correct? So AX and AY. Cos theta is equal to AX by A. AX by A. Okay now? 1 second here. One second. Okay, right. So these are the situation. This is a vector can be resolved easily into two components, 5, 3, 4, and whereas this A is resolved into AX and AY. This is a resolution. Resolving a vector means in the same way here we can resolve any vector into two components. Let's consider some force is acting, mg is acting in this direction. Okay, na? mg is acting in what direction? Let's consider. Take any force. Let's consider. Some linear momentum is acting in this direction. This linear momentum can be divided into two parts. Two types, means two. This is one px and this is another one py. And this is a horizontal component, whereas this is a vertical component here. Okay, na? A linear momentum can be resolved into two components. One is px and the one is py. Two components here. This px, what is px? I can write here. Px is equal to p cos theta. It was making angle theta at this side, okay? And py is equal to now. I can write as p sin theta. P sin theta. Correct? Means we can resolve a vector into two components. We have to understand this one. Okay, now? From this we can get more clear about the remaining things. Okay, fine. Listen carefully. Now a vector finally resolved into two components. That's what we have drawn here. Okay. Now what I want to say here is force here. What is force? Means a linear momentum we have seen in the last class, that is mass into velocity. Correct? Mass into velocity. Right? What is force here? Many of you, if I ask the definition, what is a force? What is a force? Many will answer as some mass into. Yes, yeah. Come again. Some technical issue. Okay, fine. Force. What is force? Force means here. Many will answer as force is mass into acceleration. Force is mass into acceleration. Force is the rate of change of linear momentum. What is it? Rate of change of linear momentum. Force is the rate of change of linear momentum. Understood here? Force means rate of change of linear momentum. Coming to this, changing momentum means I can simply write this one as P2 minus P1 by T2 minus T1. Means changing momentum by time. Rate means with respect to. I'll tell you one more case for some more examples here for easy. Okay, na? So if you observe here, what is velocity? Velocity means some rate of change of displacement. Rate of change of displacement. ds represents final displacement minus initial displacement. By time represent dt means final time minus initial time. But again, this is a rate of change of displacement is velocity. And now coming to the acceleration. What is acceleration? Rate of change of velocity. Rate of change of velocity means I can say this one as v2 minus v1 by t2 minus t1. Understood it? T2 minus T1. In the same way, we have the power also. Power means rate of doing work. Rate of doing work means W2 minus W1 by T2 minus T1. So what I mean to highlight here is change with respect to time. Velocity change with respect to time. Work done with respect to time. Rate means with respect to time. What's it? Rate means with respect to time. With respect to time, the change is called as but means in this situation, what I'm going to see here is change of the momentum with respect to time. Momentum is changing with respect to time. Yeah. As we see, the momentum means final momentum mass into final velocity minus initial momentum mass into initial velocity. Okay, by time, change in time, t2 minus t1. Correct? Okay, now. So you can write these expressions. Take m common one. V minus u by t2 minus t1. V minus u by t2 minus t1. If you observe here, m into change in velocity by change in time. Change in velocity by time means rate of change of velocity. Rate of change of velocity means acceleration here. Therefore, I can simply say that the force is nothing but ma. Simply formula based means this one. Actually, the basic definition is this. The rate of change of linear momentum is nothing but the force. By applying some force on a body, the momentum is going to be changed. The change with respect to time is nothing but force. Okay, na? The change with respect to time is nothing but force. Okay, one more time here. Force is nothing but rate of change of linear momentum. Momentum changes with respect to time. Change dp indicates final momentum minus initial momentum. Okay, so final momentum m into v, initial momentum m into u by change. So the rate of change of velocity is nothing but acceleration. Therefore, the force is ma. Force. Okay, by applying a force on a body, the body may state of change its velocity. Okay, it may change its motion. Okay, maybe its direction, anything here. Okay, that's what we are going to see here. Now we have different types of forces here. Different types of forces. Once we'll see one by one. Okay, let's consider. Here I'm keeping a body of mass m. A block of mass m is kept on a table. On a table, I'm keeping a block of mass m. On a table, I'm keeping a block of mass m. Now, what is the force acting on this by the gravity? Okay, now, what is the force acting on this body by the gravity? The force which is acting on this body by the gravity is mg. Why? Because as we know, the force is nothing but ma. Acceleration given by the gravity means a is g. A is g. So I can take this one as F is equal to mg. F is equal to mg is the force acting on the body at mg. Always remember this point. The force is a vector quantity. The gravitational force is mg. So it acts always downward. Okay, now it's always acts downward itself. G is the acceleration due to gravity. This acceleration due to gravity always acts vertically downward. Mg acts vertically downward itself. Okay, na? Mg force acts on the block of mass which is kept on a table. This Mg acts vertically downward. M is the force applied on the body by the gravity due to gravity. Got it here? So in this way, this is the force which we have. Okay, and I will tell you one more. This mg, the same mg is going to be acted even here. Let's consider. I am taking an inclined plane. This is called as inclined plane. What is it? Inclined plane. So here I am keeping a block of mass m. Here I am keeping a block of mass m. Here I am keeping a block of mass m. What is the mg direction? Mg acts in this direction itself. Understood it? This is we commonly state as some inclined plane. Inclined plane. Understood here? Inclined plane means making some inclination. Okay, with the horizontal, this surface is making some angle, some like from the bridge on the from over the bridge you're coming down like this. From a flyover you're coming down like this. So in that situation, mg acts here. Mg acts throughout the earth. Okay, if the body is under some mass, means mg is continuously acts on the body. This mg also acts vertically downward itself. Anything here, you take one more example. I'll take one more example here. Here a block of mass and is kept here. A metal sphere is suspended is suspended from the rigid support with the help of a rope. With the help of a rope. Understood here? What is the force? Yes, gravity is acting downward. Yes, gravity is acting downward. Gravity is acting downward, vertically downward. Mg is acting downward, compulsory. See, in all situations, this mg acts downward itself. Okay, or I'll take the same inclined plane, I'll draw like this here. This is an inclined plane, again I'll take this one as again inclined plane here. Okay, again I'm taking this one as an inclined plane. In this situation, if you observe here, this is a block of mass m. Even on this also the weight acts vertically downward only. Okay, now in all these cases, when a mass m is placed, maybe on the table or an inclined plane or another inclined plane or suspended from the rope, even in all these situations, this mg acts vertically downward. This mg acts vertically downward itself, no doubt in it. Okay, na? That's where to understand. Force is a vector quantity. Force is a vector quantity. So when it is force is a vector quantity, this mg, the quantity, the magnitude of the force is mg, and the vector acts downward. Direction also we have to give. We have to give the direction to this here. We have to give the direction also. We have to give the direction also. The direction of mg is always downward. Any situation you have to take it. Okay, or we can take one more like this. I'll draw here. What is this here? Car. Yep. So from the roof of a car, a sphere is suspended like this. Sphere is suspended like this, right? Now the car is accelerating, going with high speed, very high speed. Then the pendulum moves, okay, and then the pendulum moves, then the pendulum may stay like this here. Okay, even in this situation also the mg acts downward only. In any case, the mg acts vertically downward. Mg acts vertically downward, 100% here. The one force which is acting on the body of mass m by the gravity is mg. Okay, as we have seen now here, till now I think so. Just we have seen the momentum here, and we have seen what is force. And in the force we have seen mg, gravitational force. The force acting on the body of mass m by the earth. Okay, na? Understood here? The force acting on the body of mass m by the gravity mg, vertically down. Okay, fine. In this situation, I'll see one more force here. The one more it is normal force. I'll tell here. Same block m is placed on a table. Placed on a table. What is the force acting on it? Mg is a force acting on it. Mg is a force acting on it. Correct? Mg is a force which is acting on the block of mass m by the gravity. At the same time, if only this force is acting, this body has to move down. Listen carefully, very important point. If only this force acts on this m, then the block m has to come down. One more time, listen carefully. See, only this m as m is acting on the block, only this mg is acting on the block, then this mg has to come down, but it was not coming down. It was staying there itself. It was at rest. Of course, mg is acting. even though it was not coming there. Understood here? Here mg is acting on this even though the body is not coming down. Means what can I say? I can say some other force is acting in upward direction. What's it about? Some other force is acting in upward direction here. Some other force is acting upward direction. The force which is acting here, I can say it's a naming it as a normal force. What's it about? Normal force. What's it? Normal force. How this normal force? That's what we are going to see now. Okay, na? Listen carefully. Okay, na? Normal force. Mg is acting downward and the normal force is acting vertically up. Correct? So in this situation, what happens here is this normal force is acting perpendicular. Very important here. Very important. Very important. Normal force is acting. Correct? This normal force always acts perpendicular to the surfaces in contact. I'll tell you one more time. This normal force acts perpendicular to the surfaces which are in contact. Perpendicular to the surfaces which are in contact. Understood here? So if you observe here I can take this one here. This is the body surface, right? Body surface is there, and here I am having the table also. Two surfaces which are in contact. Here table and the body both are in contact. Here table and body both are in contact. Understood here? Here table and body both are in contact, right? Right now, for this surface, this force will be, just see this one here, see this surface here, this is a surface and the normal force is like this. How this angle, what is the angle between these two? 90. Got it here? 90. So this is 90. That's why we normal. 90 means normal force. What's it about? Normal force. Understood here? Normal force. Contact. In contact. Understood here? In contact. Okay, na? So if you observe one more time, here, this normal force always acts perpendicular to the surfaces which are in contact. This normal force acts on the body, on the surfaces which are in contact, perpendicularly. It acts perpendicularly. That's a very important point here. Normal force always acts perpendicular to the surface which is in contact. Perpendicular surfaces which are in contact. This is the surfaces which are in contact here. For these surfaces, this normal force acts perpendicularly in this. So we are calling this one as a normal force. Understood here? Okay, now today we have seen two types of forces. We discussed two types of forces here. One is force by the gravity. Force by the gravity. What is the force by the gravity? F is equal to mg. And this one acts always perpendicular, always downward, vertically downward, always vertically downward. This always acts vertically downward. Understood here? This always acts vertically downward. Whereas another one I am saying that one is a normal force here. How this normal force acts? This normal force acts perpendicular to the surfaces which are in contact. Perpendicular to the surfaces which are in contact. Understood here? Much important. Perpendicular to the surfaces which are in contact. This normal force always acts. See here, has it taken here? This is a table. Okay, a block of mass and is kept here M. Okay, now? And what are the forces acting in this situation? I can take this one as a mg. And I'm saying here one more, that is the normal force. What is the normal force? This is the normal force. Correct? Where it was acting here, where it will act? It will act perpendicular to the surfaces which are in contact. These are the two surfaces here which are in contact. Okay? These are the two surfaces which are in contact. For these surfaces, these will act perpendicularly. These will act perpendicularly. Got it here? Understood? These will act perpendicularly. This normal force acts perpendicular to the surfaces which are in contact. Much important thing here. Understood? Much important thing here. So mg acts vertically downward, whereas the normal force acts not upward here. Perpendicular. So do not say upward you will answer upward. No, no, no. It's a perpendicular to the surfaces which are in contact. Very careful. mg acts vertically downward. It's a 100% no doubt. But normal force acts vertically upward. Okay, na? So these are the two forces which you have seen in today's class here. We'll continue in the next class here. Bye. Take care.